So those are just a couple of slides from XKCD to introduce lightly the subject. So I wanted to do a presentation on a bit more advanced topic on Git, because a lot of people use Git in their work every day, and a lot of people don't really know about Git. So I can't do everything in 1 hour. I have chosen to not work on the architecture kind of thing that is covered in a lot of talks, and I'm more going to talk about some commands that you might not know, some patterns, and at the end I will try to put that all into a practical example. This is my nice slide to introduce the company next Friday. You know the company, I hope. So I'm going to talk about Git, which is the gastrointestinal tract. Oh, sorry, that's my medicine slide. So Git is this guy. I found this visual of Git, and it made me think about this. You know it? Okay, most of you know it, I hear. So I'm not going to talk about the easy beginner stuff, although you could say that this is not beginner. I'm not going to talk about that. I'm rather going to talk about weapons from later in the game. So we're going to talk about Git rebase, Git bisect, or some interactive things. It's a bit bright, but there is no light anymore. Okay, so I'm going to cover just a couple of basics to be sure that we are on the same page with a couple of words. And then I'm going to talk about some diffs, some technique to do diffs. I'm going to talk about the logs, plural. I'm going to talk a lot about rebase, because that's one of the more advanced way to use Git. Interactive manipulation, that is going to help you, as human, work with cleaning your Git flow. And then I'm going to try and do a full workflow in front of you, which might not be completely super easy. We'll see. So the basics. So some architecture basics. Commits, it's a collection of diff. Okay, so a commit, it's a change on a line, a change on several lines, a change in file, in different file. And you commit all that, and you can call it also a patch, and it's just a recording in some kind of format of this change. A repo, it's a collection of commits. So commits are forming an oriented graph with commits referencing their parent with an S sometimes when you have merge. And that constitutes a repository, so it's a collection of commits. And finally, and most importantly, a branch is simply a pointer on a given commit. Okay? And the pointer is called add when you are on the branch. And that's very important, because that means that actually a branch, you can move it around without changing anything in your repository. You can just say, well, this branch, it used to be on this commit, now it's going to be somewhere else completely. And that's something you can do very easily, and that's something that is, for example, very useful when you want to revert some work you have done, and that is, that needs to that you need to revert. Okay, so let's try to look at some interesting diff techniques. So classical diff, and I don't think you're going to be able to read much of that. You would get this. So I have changed this base variable. It's now called base image here. You might see it, base image. I don't know if it's very readable. That's what you use as the standard diff. Okay. When the first command I want to show you that you might not know is this one, the diff -- cached. This is something I use always. So diff, it's going to do a difference between what is changed in your local repository and the latest commit. Okay? If you add your file, if you do git add and you add your change, they are now in the so-called index, and when you do git diff, it doesn't appear anymore. Okay? Git diff -- cached is going to be a difference between your index and your latest commit. What that means is that when you do git diff -- cached, you know exactly what you are going to commit if you do git commit now. Okay, because that you might not have put everything in the index, and one of the things I'm going to show you is how to not put everything in the index. And so this one is very practical when you have put a partial thing and you want to be sure what am I going to exactly commit if I do git commit now. Okay, a small hint, that's something I use by default, git diff -w, it's ignore white space. So that's my default, because I don't want to see indentation change by default. If I want to see it in a very particular case, I will reactivate it, but I have aliases all over the place, and if I do git d, it's just going to do a git diff -- it's going to do a git diff -w for me. Okay, so that was the easy part of diff. Some more advanced feature. So Git 2.9 was released not long ago, months or two, and there are a couple of features that are quite interesting. So the first is compaction heuristic. So this is something in my git config that you can add in your git config, and what it does is something like that. So this is some Ruby code, and what I have done in this code is that I have added this block on top. And what you see is that the diff, because this line here and this line on top are the same, the diff thinks that I have changed the middle, whereas actually I have changed the top. I think you have seen that happen a lot of times. It's because it's trying to be very eager and to go as far as it can in terms of the line it thinks have not changed, and it takes the latest possible lines that have changed. So if you activate compaction heuristic, it's going to try and figure out some block logic based on new lines, blank lines here. And with compaction heuristic, it's going to show you what you have really done when it works. It's just a heuristic, so sometimes it works, sometimes it does not. And in this case, it shows me that I have added this top block, like I have actually added this top block, which is a lot better. So that doesn't cost anything, why not activating it? The most interesting thing of Git 2.9 is this. This is something that's called pager that has been existing in some UI tool or in the command line if you were to install external things. Now it's packaged in Git, and what it does is that on top of giving you the lines that have changed, like here, it's also giving you the part of the line that has changed in bold, or in a terminal, bold becomes highlighted. Okay, so I see that base has become base image here, and up till here, this is the part of the line that has changed. This is quite practical. And the last thing that is mostly useful when you look at diff on text, or like in this case on variable rename, is word diff. So word diff, rather than trying to diff lines and blocks of code, it's going to diff really the minimum amount possible, not characters, words. So here you can see that base is surrounded by minus, that means it's removed, and you have base image with pluses, that means it is added. And you can see inline that this variable was changed to that one, and here also. So it's a bit, sometimes it's a bit more practical to use. It's just nice to know that you can do that kind of thing. Okay, so that was diffs, to warm up a bit. Logs, not much harder. So the first log that you know, I hope, is git log. So git log gives you the list of the latest commits, okay, well, of all the commits actually, the latest on top, and you can scroll down infinitely to your repository. Git log-p for patch gives you the same thing, the commit message and everything here on top, but on top of that, it gives you the changes inside that commit. So that's quite nice to see the latest few commits. You want to see the changes. You don't have to open up a GUI and click on the commit and see commit by commit. You can see everything in your terminal, if you like terminal. You do. That's obvious, I think. One other thing that is nice with the log is that even in terminal, you can have some nice presentation like that. So my git log, by default, it does this very, very long comment, and it gives me that. So it gives me a tree view of my Git repository, which is nice when I have a simple graph. When it becomes very much more complicated, I will use a GUI, because sometimes it's practical, at least to visualize, but you can get that feeling with ASCII art inside your console, and you get the short SHA-1, you get the hour, the time ago it was done. This is all this big comment, whatever. And the most important one on this slide is this one. So any command you do with git log, you can append -- and a file path. And it will apply this git log command only on this file. So if you know that a file has changed, and in the past, you want to see what has changed in the last 2-3 commits on a file, you will do a git log-p -- and the file. And you will see only the history for that file. And that's very practical when you're tracking a bug, for example. And with git blame, you would see only the latest changes and or latest changes per line. Here, you see really, you go as far as you want, but on a single file. I did not know that one. I haven't been doing that one for a long time, and I use it all the time now. Okay, so that's the easy log. There is another log that is less known. That is the ref log. Who knows the ref log? Okay, so it's less now. That's cool. Okay, so the ref log, rather than being a log of the commits, it's a log of the operations that you did on a repository. Okay, what that means is that here you can see that I did some rebase and I did some checkout in the past, some merge, checkout, rebase. That's the operations I did in my repository. And what is great about that is when you rebase, you have changed your commit history. So basically the commits you are coming from after a rebase, it doesn't exist anymore. You don't see it. Okay? You see what I mean? It's clear for you when you have rebase because you have changed your history. The original commit, you don't see it anymore. It still exists until it is garbage collected, but you're not seeing it anymore. Here, you can go back and revert to rebase because it knows which commit in which commit was the repository before an action. Okay? And what you can do, for example, is that you want to nullify this all rebase. So this all rebase used to be at this particular SHA-1, F241D60, and you can do, for example, git reset hard and the SHA-1, and your current branch is going to move back to whatever that commit was, which was before the rebase. Be careful with reset --hard. I use it a lot, but it also completely erases whatever local change you have, and that is not committed. Okay, so just a bit of being careful there. Okay, so that's the ref log. Yeah.
Does that also delete the values out of the ref log? The reset?
No. So you are going to add a new operation that is reset hard. And so you are going to be able to revert this revert, well, if you want. Yeah, it's only additive. So a couple of shortcuts that the first one I think you know, which is this tilde character. So if you have the name of a branch or a SHA-1 of a commit, anything that points to a commit, and you do tilde and a number, it points now to X commits before that SHA-1, that add, that whatever. So it's practical, for example, when you want to go back 2 commits in the past, on your current branch, it's add tilde 2. Okay, if you want to see the difference between now and 3 commits in the past, it's git diff add tilde 3. Okay? If you want to see the difference between now and your master branch 3 commits in the past, you can do that also, master tilde 3. Okay, things like that. Well, this one is known. Now that I've shown you the ref log, you might have seen in the ref log there were those references inside the display. So those are X operations in the past with respect to whatever branch you specify here. Okay, so you can go X commits in the past with respect to a current branch, so you use add, but you can go X commits in the past with respect to another branch, and that I'm going to show you with an example live afterwards, because that can be helpful. Okay, that's the log. Cool? Okay, a nice, but not very, that you won't use very much, but when you use it, it's just great. It's this guy, git bisect. Who knows git bisect? Oh, okay, a lot more people. Okay, so git bisect is useful when you need to do dichotomy on a repository. So you have a bug, and you cannot track it down. I had that once in my life, and without the command, I would have never found it. It was the inclusion of a new library that created some mess, whatever. So you have a bug, you know it's in the recent past, but you cannot figure out where it is and what introduced it. What you would do is you would go 50 commits in the past, for example, and see whether your bug would be there, right? And, well, no, it's not there. Okay, so you go 25 commits in the past, and each time you divide your search space by 2. Okay, that's the dichotomy. Git bisect will do that for you. So you will say, okay, git bisect start at 50 commits in the past, and then Git will ask you, okay, is it good now? And you say, oh yes, it's good. Okay, it goes on its own, 25 commits in the past, is it good now? And by asking you the question and moving on its own, it's going to narrow down the one commit that created the bug and that you're looking for. And if you are into automation, and if you're in the case in easy enough, you can write a script that will do the test automatically, that return 0 or 1, a shell script, and you pass that to git bisect, and it's going to find the commit automatically for you by running the test on its own. But you cannot always write the test, or it's not always efficient to write the test first. So that's a usage of the log that is nice. You don't use it a lot, but when you need it, that's nice to know. Okay, So the biggest part of the talk is going to be about rebase. This is something I personally like. This is something we have chosen to use in the web team. And I'm going to talk a bit about it, and I'm going to show you also afterwards. So rebase, that's my medicine. That's why there is something that's called rebase. That's a medicine in the US, whatever. Okay, so a bit of legend. I have done some graphs. So master is going to be my blue line on the far left. The staging or develop, whatever you call it, is the integration branch in green just next to it. And then we have some feature branch that goes to the right, on which we do development. Okay, you don't develop generally directly on develop. Okay, so why would we want to do rebase? What is a rebase, and how do we rebase? That is a picture of the cloud repository 5 months ago. Okay, I can't make any sense out of that. Okay, you have branches getting out of here and merging, well, branching again and merging here and here and here. I can't understand anything. So if you have to work with the history, you're screwed. Okay, that was my personal experience when I arrived. If you need to work with history, you're screwed. So you have to basically, the good thing with Git that gives you a history of everything that has changed, where you can track, go back to a state which worked and everything, you almost cannot do that with it, with this kind of repository. Instead, I want that. I want my master to be very straight, my staging to merge from time to time into it, and I want to see nice branches next to one another for features that come one after the other. So we are actually working like that, right? We are all working together on different features. Sometimes I have 3 features at a time, some waiting approval, some that needs to wait before I can merge them because I'm waiting for some production condition, whatever. I'm really working like that. But at the end, I want my history to look like that so that it's usable. Okay? So that's the first reason, having a history that is usable. That's the first reason to use rebase. The second reason is merge commits. So if you do a merge is I take a branch, develop, I take my feature branch, they have all evolved differently for a while, and then I want to make them merge. Okay? So I have to resolve conflicts between 2 different complete set of commits that can be quite extensive. Okay? And all those conflicts are going to be resolved in one single commit, that is the merge commit, and that is going to be, semantically, we don't know what that is. Okay, that's just the concordance of 2 different branches. So in here, that's a real commit that I found in the repository. I have some UI changes with some feature changes, but I cannot make any sense of this commit. And if there is a bug that found its way into this commit, you cannot do anything about it. So it's hard to track. You cannot revert that because you have to manually go and remove the one line in the middle of that is wrong. It's a mess. So merge commit, it's a mess. I don't want that. So I actually want merge commit because I want to see my branches, but I want them to be empty. Okay, so that's the 2 main reasons why. And another reason why is that I'm not the only one saying so. So it's important enough that GitHub, on pull request, you used to be able to merge pull requests with 1 click. Now you can rebase and merge pull requests with 1 click. We don't have that in Bitbucket, so sorry. We have to still do that by hand. Okay, so that's the reason why I like rebase, and I think there is a reason to do rebase. So what is a rebase? That is a real commit order, okay, in chronology. So we have master, we have develop, I am working there, Tom is working there, and James is working there, okay? That's the real history. So Tom and I branched at the same point here. I worked, he worked, and then I merged before it, okay? If I do a merge logic, it's going to end up like that. So we are going to cross each other here, here, here. We have all those merge conditions that I don't want to see. A rebase is going to look like that. So it's going to be as if Tom has actually worked after me, and James has worked after Tom, and so on. And it's very easy to go in the past. So those merge commits, they are empty. I keep them just so that we see the shape of the branch, so that we can see that those 3 commits, they go together in the same feature. But actually the branch is useless because this commit is completely empty. If it's not, I have done something very wrong because I have merged something with nothing in parallel. So it should be empty. So that's what a rebase is. Okay, that's rewriting the history, the order into which you did your commit, so that it so that it does something different. So in this case, so that the history is usable and looks much better. So how do you do that? So I have done my branch, I have merged, Tom is there. What does Tom do? Tom wants to merge. Okay, he wants to incorporate his changes into our integration environment. So first, Tom is going to rebase on develop, which is where he was starting from. Okay, so the rebase, what it will do, it will take the two commits from Tom here, and it will just remove them from the commit tree. Okay, it will put them in some side space, some kind of stash, whatever, you don't know, you don't care. It's removing them. Then it's going to check out develop. So check out in develop means Tom repository will now be here. Okay? And then it's going to try and put those commits one after the other on top of wherever Tom is now, which is the new reference point. Okay? So that's, and you are going to have to sort conflicts along the way, right? And so that means different things. The first thing is, about conflicts. One of the things that people say that they don't, the reason they don't like rebase is that conflicts are harder to solve with rebase. That's often what you hear. That's completely wrong. It might be a bit longer because you might have the conflict several times. It's not harder because it's the same conflict overall. Okay, you have the same line conflicting. The difference is when you merge, you create one commit that resolves all the conflicts of 10 different merge on the left, 10 different merge, commits on the left, 10 different commits on the right, and you try to make sense of it all in one go. You try, I say, because most of the time you fail. Okay? What you do with rebase is that because Git is now here and it's trying to put this commit here, it's going to say, oh, I can put the commit at this place for whatever conflict. And you are actually going to change this commit, which was I refactored this method and I changed its name. Okay? You are going to actually put it there. It's going to conflict. You are going to solve the conflict. And when you are, it's going to create a new commit that is semantically still the same. It's still the refactoring. It conflicted because I changed some method that Tom renamed. So I'm gonna have to resolve that. But semantically, it's still the same commit. And that's super important because you keep the semantic of every commit you do. And if you do unitary commit with single purpose, that's obvious. And so the problem is that if you don't rebase often, if you have long-lived branch, well, you might change several times in several commits the same place of the file, and so you feel like you have the same thing to redo again. And actually, you have some configuration you can do to not have that. I had something else to say, but I don't recall about conflicts. Okay. Oh yes, about conflicts. This is something I never understand about conflicts. When you do a three-way merge, you have theirs, ours. Or now they say local remote also. Okay? That's always a mess for me to understand. When you do rebase, because you are locally now here, and you are trying to apply that. Local is that, so it's actually the work that the other did, and remote, or theirs, is that. It's actually your work. It's very confusing when you don't understand why. And that's why the hours there, they renamed into local remote. It's still a bit confusing, but a bit less, because hour there, it was really completely frustrating. Okay, so you end up with that guy. Now Tom has remerged, has rebased, sorry, so git checkout, put first commit, put second commit, all on its own. It asks you to solve any conflicts along the way, if there were any. Now Tom can merge, and the only question he has to ask himself is whether to fast forward or not. So what I said is this branch here and this merge commit, it is empty because I have nothing to merge with because there is no work on this left side. So it is useless to still see the branch. So actually, by default, Git will do that. It will say, well, the branch is useless. Let's put all the commits in a straight line, which is nice. Why not? I like that because that means that the commits that were done together on a feature branch, they stay very visibly together. Some people say, well, in the commit message, you started with your Jira, so you still see the grouping. Well, I like to have that. So to be able to add that, you need to tell Git when you do your Git merge, you need to do -- no ff, which means no fast forward. And actually, I don't type it every single time. I have it in my Git config. It never asks me. It never do a fast forward. Okay, so I always get this branch shape even if by default it would disappear. Okay, but that's a personal preference. That's what we chose as a team in the cloud team. It's open for anyone to use differently. So there is one, I think, maybe two big caveats with rebates, or not caveats, but things to be careful with. Sorry, when you're in this particular state, your local branch is here, and you want to push it, okay, to your remote repository for safekeeping, for example. If you try to do that, it's going to fail. And it's going to tell you, well, you have some commits that are on remote that you don't have that int. Maybe you should git pull. If you do that, you screw yourself. Okay, you should not git pull. So why? So this is your local repository. You have changed your history. So those two commits, they used to be somewhere below. They used to be here. And now you have changed them. They are here. So as far as Git is concerned, those are two different commits. They have different names. Their unique name is the SHA-1 that's computed from the content of the commit, whatever. They are different. So Git is actually telling you, those two, they are on the server, on the remote, on origin. You don't have them. And those two, they are local. The server does not have them. Okay? But actually, this situation is because you completely change your history. Okay? So your local state is the one that is right. So you want to just tell the server, well, I know what I'm doing. Okay? So you would have this error message, rejected. Maybe you should git pull. No, you should not in this case. I will show you maybe a bit later, but in my terminal, I would have this nice icon that tells me there is something up, there is something down. So I can see that I have a kind of conflict state here with my two remote and local. And so in this case, you do not git pull. Otherwise, you do some kind of merge into your own branch, and that visually you will see that you have done something wrong. You open a visual tool, and you will see that your repository looks crap, and you will see there is something wrong. And in this case, you need to git push force, okay, to say to the remote, I know what I have done. Okay, git push force is like a bomb that can blow up everything. So git push force is basically, I'm rewriting what is on the server, okay, because that would not go automatically, so I need to really change whatever it is. That means that you're rewriting something that is public, that everybody sees. Okay, as long as it's your own feature branch and nobody works on it, or you work at two and you tell each other when you do that kind of thing, that's just fine. If you git push force something that is shared, like develop or master, everybody is very, very, very screwed. Okay, so actually in Mercurial, they are trying to be able to handle that, but in Git you don't. Okay, so you don't push force on staging or on develop or on master. Actually in Bitbucket you can prevent any history rewrite on those branches. That's what we have on the cloud. So if you try to git push force on our develop or our master, it's going to tell you no. Okay, so be careful with that.
What happens when you are in a shared branch? Imagine two persons are working and you push force.
It depends. So if you are able to agree at some point that you are both done with a change, you can allow yourself, one does git push force, the other does git pull. You might have to force, or you might have to reset something to force to use the current repo. It can work, right? But it's okay if you are 2 or 3 and you can say, okay, now Friday evening or whatever, we are all done, we are going to rebase. But it's basically the best practice tells you should not have those kind of long-lived branch and everything. We work on the web. It's also easier because we release daily and we have shorter cycle, okay? So some of those things might not apply. And also, I'm very strict about doing that, but you should never be completely strict. So there are cases where you are going to do rebase 90% of the time, and sometime you are going to have a long-lived branch to do some hardcore refactoring, and this one you're going to merge without rebasing. That depends. But if you're not strict, you never do it. So we start with strict, and then we say, okay, you have some exceptions. Last thing that I'm going to show you live afterwards is rebase onto. So the syntax is git rebase -- onto some target from what? So from what you rebase, what you are rebasing. So what, it defaults to the current branch. So I like to work with, I like that git action always work on my current branch if I don't tell it otherwise. So I never say the what on any command. When you do git diff or whatever, you can always specify things. I never do. So I always work with the current branch. It's way clearer in my head. And from, it defaults to current branch remote, upstream. It's a bit messy, so that this one I always say what that is. So what it is doing is that it's taking all the commits between from and what. Okay. So what being the tip of your current branch generally, and from being, for example, your fork point. That's what makes sense. And it puts them on the target. So one of the use cases that I described here is you have a bug, a reported bug, and it's a small bug. So you branch from develop, and you fix your bug. And then someone realizes that it's actually a very complex, a very important bug because it has some downstream impact. So all of a sudden, it's a hotfix. Okay? So the complicated or more labor-intensive way is to create a new branch from master and cherry pick the commits. Okay? The easier way, once you know it, is to do rebase on 2. So you rebase your entire branch. It used to be from staging, you put it on master. There is another use case that I'm going to show you live afterwards. Okay, last before the live show is interactive manipulations. So why should you care about those interactive manipulations that I'm going to show? The best practice that you find is that commits should be unitary, single purpose. Okay? The reason for that is that it's easier to follow in the history. If the commit is doing just one thing, renaming a function, adding a new library, adding a feature, it's way easier to follow. It's easier to review when you are doing your pull request or code review. If you have commits that have a single purpose, it's much easier to understand why this line was changed. It's in the purpose of this particular commit. Okay, it's not a commit for whatever I have done in the past week, which I have seen. It's easier to revert if needed. Okay, if I have a bug on a new feature, I want to revert just the new feature and not the 3 other bug fix and the comment refactoring and the test that I did. Okay. And well, it's a bit the same. Easier to isolate a change creating a bug. If you commit once a week, well, the bug is somewhere in the week worth of change. If you commit 10 times a day, you have a lot less things to revert or look into when you have found the culprit. As humans, however, we are not capable of that. I'm not at all capable of doing that kind of thing. I always do miss something. I always do 2 things at a time. And I'm not capable of doing this. So I need those interactive manipulations. So for example, this is a real stupid yet real example. I did some code here. I needed to decommission some of the code because this feature does not exist anymore, so I needed to remove it. So this is real code. And then I took the opportunity, I saw a big file full of mess, so I took the opportunity to remove some of the other things also. This is a stupid example, but still. This, if for any reason I have a problem with that, and I need to revert it, for example, I don't want to revert my cleanup, for example, okay? But I have done it at the same time. That's just how I am. So I want to do that in 2 different steps. So what I'm going to do, and the code is not the same, is that I'm going to do git add -p. And I don't recall what -p means. I think it means patch, but whatever. And git add -p is going to be git add interactive. So rather than adding so git add -p and then dot or a file name or whatever. And what it's going to do is that rather than adding the entire file or the entire list of files into the index, it's going to ask me chunk by chunk, do you want to add that? So here I have a file. It's not the same, sorry. Some Ruby. I think it's the file we are going to see afterwards. This is one of the chunks. Okay, do you want to stage this chunk into the index or not? And you can reply yes, no, quit, all, and you have some more fancy things afterwards. If it's too big a chunk it gave you, you can ask it to split it, and when it cannot, you can also edit it completely. And so you can basically, line by line or even character by character, control what you are going to put in the index. And that's where it's very important. So sometimes I put half a file into the index, and that's where my git diff -- cached is very nice, because then I do that and I know exactly which part of the change I'm going to commit, if I do commit, okay? You can actually do that also with reset and checkout, although it's very odd because reset is trying to remove a patch, but you're still editing the additive patch. So it's very odd, so I do git reset and then I do git add -p. You can do it the other way around if you know what you're doing. Last thing, git rebase-i. So it's a rebase interactive that is useful to rewrite your own history. That's something that I use a lot on my local branches that are my feature branches. And it allows you to do many things like reordering commits, merging commits together, editing commits. I'm going to show you that live afterwards. So, but basically, you have those 4 commits. So you do git rebase-i add ~4. Add ~4 is 4 commits in the past. So and you don't put the second argument, so it's current, the current branch. And that means take those 4 commits in the past, present them to me, and I'm going to tell you what I want to do with them. Okay? So now I'm going to try and do a live demo. Just so you know, this is based on our context that we use in the cloud. We use Git flow. I think at least in the capture we are trying to do that. I don't know. I think it's something like that for the mapper. We have master that is production. It's actually auto-release in our case in production. So if we commit, it goes automatically in production. We have develop. We call it staging. We don't care. That is our integration. Anything we commit there, bam, it goes into our integration server automatically. And then we do feature branches on the side, and we rebase. We use rebase. So it's not exactly that. So I'm going to try and do an example with those in mind. So the starting situation is this guy. So I am working on some stupid Ruby array utilitarian methods. Okay, I want to sort, I want to get a max, I want to do some things like that. So I have an initial, on staging, I have my initial array utils that is just a pretty printer. I have done a branch, the sort branch, that is waiting for a PR, and I wanted to implement max, and I figured that I could do max by sorting my array first. I don't say it's very intelligent to do it like that, okay? I just figured I could. So max is actually on top of sort, okay? And while I was doing that, I or someone else worked on reverse from staging and was able to merge, okay? So I'm in a situation where sort is approved, I want to rebase it, merge it, and then max is approved, I want to rebase it, merge it. Okay? And I'm going to try to do that. And I hope it's not going to be an epic fail. So, is it readable? No. Is it readable? Yes, no? Okay. So you'll notice while I do that I have a prompt that is going to change quite a bit, that tells me everything I have to know about my GitHub, my Git state. We can talk about that just after. Okay, so I have this change currently on max. So I just worked on max. I did the implementation of max, and I end up with that. So I did the max at the bottom. Up. I did max here. And I figured that this was a small bug because there was no end of line at the end of my output. So I wanted an end of line, so I changed print into puts. Okay? So I have done 2 changes on the same file that are not related. So what I want to do first is not commit them at the same time. So I'm going to do a git add -p. So it's going to tell me, okay, this is the first hunk. Do you want to use it or not? And this one, I say yes. And this one, I say no. And then I have, so you can see if I do a git status, you can see that the file is both modified in the index and modified locally. It has 2 sets of changes that are in different places. Okay. Now I can do a git commit, and I'm gonna say that it's a, oh no, I need to do it the other way around. Okay. So git reset. So reset is removing what I have in my index. So I'm going to do my git -p again. This one I don't take, and I take this one. Then I commit, and that's my feature max implementation. Up, and I can add the rest. I did not show you that, whatever. I can add the rest, and I can do git commit -m, and that's my fix. New line at the end. Okay? Easy. Oh shit, what is that? Con -1. Ah, what? Edit, fix, git commit. Oh, yes. Alright. So there is something wrong here. What is wrong? I wanted to edit something. I think I'm going to do some code that won't work because I don't recall what I have written here. So maybe I forgot to remove it before. Whatever. I'm doing some change. And I'm going to add it, and I'm going to commit it. So actually, I realized, so what happened in my mind, right? I realized that the feature I had implemented, I had done something slightly wrong, or I missed some optimization or whatever, okay? So I can do two things here. If I wanted to change my latest commit, I would do git commit -- amend. Okay, that would rewrite my latest commit with the addition of whatever I just changed. Unfortunately, I did my feature first and my fix after, so it's not my latest commit I want to change, the one before, right? So I'm going to do a git commit, and I'm going to put a whatever placeholder so that it's obvious. And then I'm going to rebase, so rewrite my history, so do some interactive rebase, and it's my latest 3 commits, okay, my temporary commits and the 2 before. There you go. So I want to actually have this commit here next to the other one because they go together. It was actually the same. And I want to, for example, fix up. So you have it here, fix up like squash, which means meld 2 commits together, but discards the second commit log message. I don't want to see this temp anymore. Okay? And now if I do git lg, I have only 2 commits on max, the feature, the fix. If I do git log-p, I have my fix here, and I have my commit before that doesn't, it's here that I needed to put the -1. Okay, now I understand. So whatever, I wanted to change that one, but you see that both those changes are in the same commit now. That was the point. I'll try to do it better on next Friday. Okay, I've done my rebase -I. Okay, so my max is done. My colleagues have approved the sort branch. So I want now to integrate my sort branch into my develop. Okay, so let's go on sort. So you will see that sort is this guy here. I'm here, my head is here. And I want to put it on develop, that is here. Okay, it has branched because there is the reverse thing. So what I want to do is rebase. So I want to rebase sort onto develop so that it's as if I had done sort after whatever has been done on develop in the meantime. Right? You're following me? Okay. And I'm going to have a conflict. Yes! That's on purpose. Okay, and I see that here I have a conflict. If I do a git status, it says that arrayUtils was both modified. That means it was both modified by ours and theirs, local, remote, whatever. So the 2 persons. So I'm going to use a tool because I'm not going to edit that by hand. By default, I have configured my Git to use Vim as a merge tool because I use Vim. You do what you want. Ah, shit. Okay, I know why. I know why. I think I thought I did it. I will try to do it. I'm not sure I will be able to. It's not -- Aha! Let's try again. I'm not sure it's gonna work. So I want to rebase abort. So my rebase failed for whatever reason. I'm gonna abort it. So I used to be in the middle of rebase. I could see that because I was in a detached head state. I was not on a branch. I abort it. I try again. I'm sorry because the problem is that my Git is configured to remember how I resolved merge conflicts. So I need to, because I have trained on that example several times for the presentation, it has some memory of what I have done. I hope I'm going to be able to show what to show what I want to show. Yes! So I forgot my resolution before. Okay. So this is a three-way commit. So you have somewhere, depending on your UI, where is Brew? It's in a different place in my UI than in yours. So I have base that is in the middle. Base is the common basis. Okay, you have a merge conflict between two changes, and those two changes have a common ancestor. Okay, so that's the common ancestor before there was a conflict, and that's local. So actually, that's because it's a rebase. That's what the other changed. So that's what's reverse changed. It added some method, and that's remote. That's what I changed. In this very particular case, and that in the bottom is the resolution. It's the file I will have in the end. In this particular case, it's very easy. This was added at the end of the file. This was added also at the end of the file. I just need those two methods to be at the end of the file. Actually, it's not easy because there is some common part to both codes, and so this common part is there only once. Okay, so this end return results end. It's also the end of the reverse function that is not there anymore. So I put it back, I remove those markers. You can do that with some graphical tool that will help you a bit. And I have my new file with reverse and properly merge and afterwards stupid sort. So I save that, I quit. Now my merge is fixed. Everything that has been fixed is in the index. You might change something completely different. Okay, if you were fixing a conflict where actually it was due because you have changed the name of a function, you have refactored the function, and sometime I'd called it from yet another place, you could add something in there. It's going to change the one commit you are currently rebasing. Okay, when you are done, you do git rebase -- continue. Okay, and now my sort is on top of develop. There is no awkward branch with respect to reverse. Okay. What is odd though? I'm just checking that I should tell you there. Okay, I'm gonna merge first. So I have rebase sort. I go on develop, and I merge sort. I say yes. Where is my message? Hello. Up. You can do -- no edit if you don't want that to pop up. Whatever. So what does my repository looks like? Looks like that. I have sort here that has been merged on top of develop. That's exactly what I wanted. Now what you will see is that max here was based on top of sort. Okay, but you did not rebase max. You did not want to rebase this history. You rebased the sort history. So actually max is still at the bottom, and because it depends on the commits that sort used, that sort had done before, well, they are still there. So these sort and skip first element that have been rebased, they are still in the bottom. Okay, that is I chose this example on purpose. That is one of the most complex. That is when you do a feature branch on top of another feature branch that is waiting PR, for example. Okay, so what happens now? I want to merge max. Okay, and of course I don't want those duplicate commits. So the nice Git documentation tells me the same commits are going to be removed automatically. It is half right. Okay, so we are going to try. So I'm going on max, and now I want to rebase on develop, and I'm getting a merge conflict. And a merge conflict on what? On the very first commit it's trying to apply, which is a sort commit, which actually has already been merged, and the conflict's resolved. So if I do merge tool now, and this one I had forgotten, but not the other one, that's why I was getting, okay, I need to forget both resolution. This one is a nightmare. So I actually cannot figure out what this guy wants. If you look at where he has problem, I cannot figure out what this guy wants. I can fix it. So let's do it. And I have removed the minus. Oh shit. I thought I could fix it. I think it's that one. We'll see. Okay, I have fixed it. And what happens? I'm going to tell it continue, but maybe you are already seeing what's happening. It's telling me there are no changes. Because actually, because this commit is already there, and it's already merged, well, if I resolve the merge conflict the same way, it's already there. So what happened here? Git tells you I'm going to not duplicate the same commits. The problem is that those are not the same commits anymore, because when you rebased sort, you had a merge conflict. Okay? So you have resolved the merge conflict, so you have changed the commit. So now the content of the commit of the sort branch that has been rebased was different from the sort branch that had not been rebased. So when you rebase the second branch, max, the commit is not the same, it does not recognize it, so it tries to apply it again. So from there, you have a very, very ugly merge conflict that I could not really understand. I could solve it, I think, but I could not understand. If it was complicated, I could not solve it. All to end up in this situation where I have actually no change. And I can say git rebase dash skip as it is proposing me, because actually this commit is already there, so I want to skip it. But I find that to be very hard to understand from my human point of view. Okay, so I'm going to do it some completely differently. So I'm going to do abort. I'm going to abort that. So I'm in the. I know that I know that I'm in this case where I have my max that used to be out of sort. So I have those two commits. Sort used to be there. Okay. So actually, what I'm trying to do is a bit stupid, or it's not what you should do. So you should rebase a branch onto develop only if this branch was out of develop. You should not try and rebase a branch from X into A, because you don't really know what you are doing in this case. Okay? If you want to rebase from A to A, that's okay. If you want to rebase from A to B, that's the case, the last thing I showed you with the rebase onto. And here I'm going to do some combined magic. Okay? So I want to rebase max, so that's the current branch, so I won't have anything to put at the end, that's good. So I want to rebase max onto develop. It was not originally created from develop, so that's why onto is a better candidate here. From where? So what is my starting point? Yes, but source has been rebased, so source is completely in another place now. So I cannot use sort. Add -2 if I know exactly that I have two commits on top. Yes, that's what I would have done before. Now I know better. I can do, be careful, sort. I want to rebase from the place sort was before I moved it, before I rebased it. So the last action I did on sort was a rebase. Before that, it was exactly at the place I wanted. So if you do those two operations one after the other, rebase sort, and you know that you have to manage max just after, that's very convenient and you can get it in your head. If it's 1 week later, you're dead. Okay, so you have to do add -2 or whatever because you know the range of commits. Or you can cherry pick, you can do whatever you want. But that one, that's just great. Okay, so sort used to be just in the right place. Now I do that and it's applying only those two commits, which is exactly what I wanted. Okay? And I have shown you everything. So, conclusion. It works. Okay. My little conclusion. So, I am of the opinion that a craftsman, we talk about software craftsmanship nowadays, like software engineers are craftsmen. Craftsmen are people that are doing, well, it's a bit of the opposite of industrial, but they have tools and they master their tools. Okay, good craftsmen, they know their tool by heart. Mastering Git is very important because you use Git all day long, and because a lot of time you are afraid of Git, especially in those complicated situations where you want to rebase but you're not sure, where you have a merge conflict and you don't know what to do. So it's, for me, it's very important. And if you master Git, you are not afraid of Git anymore. A craftsman has several tools, and even for Git, actually, I have several. So I have Git, that's the base, and I configure Git. That's my config file, okay? Open your config file, tell me how many lines you have. It's not even very big, but I guess it's bigger than yours. Yeah, I have a small complex. So I have some interesting things there I can show you. Not very important, but what's important is, you are using it every day. You do -- no ff every time you merge. For example, I don't want to have to type it every time. So I have somewhere ff false here, which created another side effect. So I have also preserve, rebase preserve, whatever, somewhere else. So that's the first tool I use. Actually, knowing a bit of other source control system like Mercurial, SVN, is helpful because they work differently and they have made different compromise, and it can help you see it in a slightly different light that can help you do some other things. Okay, this rebase onto blah blah, the last command I showed you, that's really something that I wanted to do when I saw how easy it was to do in Mercurial. It's a lot easier in Mercurial, but I can do it in Git, and it's not too hard. I have shown you everything in the terminal because I'm a heavy user of the terminal. I code in Vim, and I use Git command line all the time. I never use a GUI to commit, push, or whatever because I don't understand what the GUI is doing, and I don't want to use a tool where I don't understand what it's doing, especially on complicated command, obviously. But I do have a GUI when I have some complicated situation and I need to see the shape of my repository. When I resolved a complex merge conflict and I did some rebase that I'm not sure how I did it, I look at what it looks like. If it looks good, there is a good chance that I did the right thing. And finally, I like very much to know constantly in which state I am. So in my command prompt, I had a lot of things showing constantly. Okay, and one of the things I actually did not show you, and I'm going to show you now, look at it, is if I do touch foo and I do stash. Oh shit, it's bad. I know that I have a stash. I always forgot I have stashes, and I ended up sometime when I did not have this command line thing, I ended up with 3 or 4 stash on top of the other, and I did not remember at all I had those. Okay, so this is very, very practical for me. Of course, if you have a very good head, maybe you don't need it. So this tool that I'm using is a tool I actually wrote because there is one on the web that was heavily known that is called Git Radar, but it's implemented in shell. It is unmaintainable, according to me, and it took a long time to run. My tool takes a lot less time, and I wanted a pet project to write some Haskell, so this is a tool written in Haskell. It's super easy to install. Whatever you choose, I think whether you use a GUI or something, you should know your tool and have some indicators that help you. So this is one that works well.